Hi there, this is MJ on the journey back to Silicon Valley. Today we're going to look at problem 1, two-sum on LeetCode. I think this is the first problem that was ever on LeetCode, but I'm not sure actually. I meant to actually Google it before this, but I ended up not doing it. Okay, so let's dive right in. So the problem here is, given an array of integers nums and a target, return the two numbers that add up to the target. And you may assume that the problem only has one solution and you cannot use the same element twice. And here are examples. So we have 1, 2, and 3. So as you can see here, this array has 2, 7, 11, and 15. The target is 9, so we need to find two numbers that add up to 9. And those two numbers here are 7 and 2. And the indexes are 0 and 1. And the same thing for example 2, we have 3, 2, 4. The target is 6. So the output would be 1 and 2, because those are the indexes that the numbers that add up to 6 are at. So my initial thought when looking at this problem was to use a two-pointer approach. And I don't know exactly why I thought that, but I kind of remembered it from another problem. So I thought of initializing a current pointer and a next pointer. And if they both add up to the target, then I will return their indexes. Otherwise, I will move them to the appropriate next index or value and do the same thing. So after writing some pseudocode and actually code for this, the solution failed 2 test cases, which I suspected was due to my flawed use of pointers. But more on that later. So I've done some research and decided instead to use a hash map. I can store the elements in there and map them to their corresponding indexes, and then I can check if the difference between the target and a current element in the array is present in the hash map. If it's present in the hash map, then I can return the current element index along with the value from the hash map. If it doesn't exist in the hash map, then I can add both of them to it. So, and here are the pseudo steps. So I'm creating an empty hash map and iterating over the array nums. So for each element in nums, I'm going to calculate the complement by subtracting the target from it. And then if the complement exists in the hash map, then I would return the array with the current element index along with the value of the complement in the hash map. If the complement doesn't exist in the hash map, then I can just add the current element index, and I can add the current element and its index to the hash map. And if no complement is found, then the function would return false. And here's the solution right here. So as you can see, we're initializing nums map, which is the hash map we're going to store the elements into, and then iterating over nums. And if the hash map has that value, if it's not undefined, then we are returning the current element index along with the value from the hash map. And if eventually we don't find the complement, the function would just return false. So after getting green check mark on LeetCode, I submitted the code, and here are the stats. So the solution is beating 95% of submissions for runtime and 39% for memory, which is not bad at all, especially for like runtime. But then the idea of like using 2 pointers just would not leave my mind. I had to find a way to use 2 pointers. I was feeling like that was the more optimal solution. And I ended up going down a rabbit hole. And before, I've picked up a lot of insights, but before I share with you what they are, let's go over the solution, and let's go over the solution actually using a 2-pointer approach. So here are the pseudo steps. So I'm initializing 2 pointers, one at the beginning of the array and another one at the end of the array. And I'm using a while loop. So while the left pointer is less than the right pointer, I'm going to calculate the sum of the left pointer and the right pointer. So if the sum adds up to the target, I'm going to return the indices of the 2 numbers as the solution. If it's less than the target, then I'm going to move the left pointer to the right. If the sum is greater than the target, then I'm going to move the right pointer to the left. And then if no solution is found, I will return either an empty array or a null value. And here's the solution here. So you can see we're initializing a variable left, assigning 0 to it, initializing a variable right, and assigning the length of the array -1, which is the last element. And then while left is less than right, if the left pointer plus the right pointer equal the target, we are console.log in left and right. What would we be without console.log statements, right? So we're returning an array with the left and right, which are going to be the indexes of the 2 numbers that add up to the target. Otherwise, if the sum is less than the target, we're going to increase the left pointer. If it's greater than the target, then we will decrease the right pointer. And so after running the code, I realized that test case number 2 is failing. So test case number 1 and test case number 3 are passing, but test case number 2 is failing here. And this was the first insight that I got from down the rabbit hole that I went to. So test case 2 is failing because the array is not sorted. And if it's not sorted, then the values wouldn't be in the correct order to find out which numbers actually add up to the target. So the 2-pointer approach is not going to work correctly because the array is not sorted. So that's the first insight. So that a 2-pointer approach actually works best only when the array is actually already sorted. So when it's coming in from the input, if it's already sorted, then the 2-pointer approach would be a good solution. So I revised my steps to actually, I revised my steps to actually use pointers. No, I'm sorry, I'm blanking out here. I revised my steps to actually first sort the array, then use 2 pointers. But it still did not clear the test case because the elements that add up to the target are at index 1 and index 2 in the original array. So 2 and 4 add up to 6. And they're originally at index 1 and 2. But after sorting the array, index 1 is going to have 3, and then index 2 will have 4. So the function is going to return 0 and 2 instead of returning 1 and 2, which is the correct answer. So I tried to fix it by actually sorting. So the sort function in JavaScript sorts the array in place. And so I decided to sort actually a copy of that array. And then when I'm returning the indices, I'm going to return the indices from the original input array nums. And here's the solution right here. So basically I've added it's the same code as before, but I've added a variable called sorted, and in that variable I'm copying whatever is in nums. I'm copying whatever is in nums, and I'm also sorting it. And then when I'm returning the indexes, I'm using the index of to return the indexes from the original array. And so this solution did pass for test case 2, as well as test case 1. However, test case 3 was now failing. And this took me like a while to figure out, but I ended up discovering that, yes, I'm returning the indices from the original array, but index of itself in JavaScript would return only would return the index of the first occurrence of that element. So it won't return. So in this case, we have 3 and 3, which is a duplicate number. So 3 is both at index 0 and at index 1. But using index of is only going to return index 0, which is the first occurrence. So that was the other insight that I've picked up from down the rabbit hole, that a two-pointer approach works best if the values of the input array are actually unique. So using a two-pointer solution is the optimal solution, but only when the array is sorted and the elements of the array are actually unique. And those were not the only insights I've picked up. Like, I learned a ton of stuff. Also, when it pertains to using JavaScript to solve this problem, but these two insights should suffice for the purposes of this video. I did think of how to actually solve for being able to actually return all occurrences of the to return the indexes of all the occurrences of the elements, but then again, that's going to involve more time and memory complexity. And I ended up just like resting my case, so to say, that a two-pointer solution is not the right approach for this particular problem. So in conclusion, basically, the two-pointer approach has a linear complexity when it comes to time, but a constant memory complexity, while a hash map has both linear memory and time complexity. So both approaches are suitable to solve the problem in a linear time complexity, but the memory is better if you use a two-pointer. So basically, it will come down to the requirements that you have to solve the problem. If memory is not an issue, then you can use a hash map. If memory is an issue, then the optimal solution would be to use a two-pointer approach. And by the way, a two-pointer is also called a sliding window, because if you can like picture a window that has two sides, which is left and right, and the problem is being solved by the pointers either moving towards each other or moving away from each other, the way a sliding window would actually do it. And I think that's it for this problem. This was MJ on the journey back to Silicon Valley.